Hello students, Algebra 1 students. This is help with lesson 83. Problems that were on the board. The first one is number 7 on page 344. The problem is if f of x equals x cubed plus 2, what is the value, or find f of 3? This is what we plug in for x in the equation. So it's 3 cubed plus 2. So that f of 3 equals 3 cubed is 27. 27 plus 2, our f of 3 is equal to 29. That is our solution. That's number 7, problem number 7. Okay, number 9 says find the domain of this function. F of x equals the square root of 9 minus x. This is one of our limitations on the domain. Remember, what's under the radical has to be greater than or equal to 0. It's all reals except this limitation. So I subtract 9 on both sides. I have negative x greater than or equal to negative 9. I don't want to know what the opposite of x is. I want to know what x is. So I multiply both sides by negative 1. When I multiply by negative 1, the direction of the sign changes. Remember, I don't lose that equal to, so I have x is less than 9. So the domain is all real such that x has to be less than or equal to 9. And remember, I graphed one on the board, and this is what that graph looks like. There is no line to the right of 9 on the x-axis. Okay, so that's number 9. Number 10 is find the domain and range of f, if I could get it on there, f of x equals negative 5. Remember, this whole value is my output, which is my y. Could be rewritten y as negative 5. When I graph that, here's my y-axis. This is my x-axis. Y is negative 5. Let's say this is negative 5. It's a, oh, that is a really bad graph. But that is f of x equals negative 5, or y equals negative 5. And so my domain, my x values, is all reals. I'll write it up here. Domain is all reals. My range is only one value. Y is negative 5. So my range is just equal to negative 5. There's no other value of y that this graph ever touches. All right, that's number 10. Number 11 and 12 are in your book, so I will go to the book. All right, so this is also find the domain and range. Sorry for the shakiness. My lowest x value is negative 4, so x has to be greater than or equal to negative 4 because that's a closed indicator. My highest x value is positive 4, so x is less than or equal to positive 4. So written as one statement, my domain is all real such that negative 4 less than or equal to x less than or equal to 4. My range is my lowest y value, which is y greater than or equal to negative 3, and my highest y value, which goes to positive 3. So y less than or equal to positive 3. Written as one statement, my range is all real such that negative 3 less than or equal to y less than or equal to 3. For number 12, we want, you already see, the answer. So they want the graph of those. The equation of these graphs. for this A, line A, the value of x doesn't change. X is always 3. Y changes. X never changes. So all vertical lines are x equals, that's 4. 4. Okay? For this one, for line B, we're going to do y equals mx plus b. Our b value is where it intersects the y-axis. It is at 0. So my b value is going to be 0. My m value is my slope. The slope is the rise over the run. So I do have a point, coordinate point at 0, 0. And then I have a point here, which is 1, 2. I calculate the rise over the run. Remember, it's the change in y over the change in x. So 2 minus 0 over 1 minus 0. My slope is 2 over 1, which is 2. I check my line, make sure I'm expecting a positive slope. It rises from left to right, so it is a positive slope. So now I plug in 2 for my slope. And actually, I don't need the 0. It could just simply be y equals 2x. Okay? That's number 12. Now we'll go to number 14. Problem number 14 says, consider these equations. Y equals 2x plus 1 and y equals negative 2x plus 1. Well, if you could see it, huh? Now, what they want to know is, are these consistent, inconsistent, or dependent? So I'm looking at their slopes. I'm looking at the y-intercepts, okay? The slopes are not the same, yet the y-intercepts are. When the slopes are not the same, they only intersect at one point. So these lines are consistent because they only intersect at one point. And my guess would be, actually my intellectual guess would be they intersect at where y equals 1. All right, that was number 14. It says check your answer by graphing. Well, you guys know how to graph. You plug in numbers for x and solve for y. So that was 14. All right, 2 more to go. Number 19. Solve x over 3 minus 2 equals 4 minus x over 5. I have an equal sign. I'm eliminating the denominator by the least common denominator. My denominators are 3 and 5. The least common denominator would be 15. Multiply every term by 15. Before I multiply, I simplify. 3 goes into 3, 1, into 15, 5. No simplification here. 5 goes into 5, 1, into 15, 3. Now I distribute. I have 5x minus 2 times 15, which is 30, equals. I distribute this 3 to both the 4 and the negative x, and I'm left with equals 12 minus 3x. Now I solve for x. I'm going to move my x to the left through subtraction. Through addition, because it's a negative over there. And I'm left with 8x minus 30 equals 12. I now move my constant term to the right through addition. I'm left with 8x equals 42. Just making sure I did all my math right. I divide by 8 on both sides. X equals 42 over 8. It can be simplified. I know both are divisible by 1. That would be 21 over, by 2, divisible by 2. That would be 21 over 4. That is the value of x for number 19, 21/4. Problem 20 is just like this. We have an equal sign. We're eliminating the denominator. Here, I have x over 4. Remember, I leave space. Minus 1/2 equals 2 minus x over 8. Now, my denominators are 2, 4, and 8. The common denominator would be 8. So I multiply every term by 8. Every term by 8. Before I multiply, I simplify. 4 goes into 4, 1, into 8, 2. 2 goes into 2, 1, into 8, 4. And 8 goes into 8 one time. Now I multiply, and that's 2x minus 4 times 1, which is 4. 1 times anything is always the other thing, so I just have 2 minus x. I'm going to move my x to the left through addition. 2x plus x is 3x minus 4 equals 2. I'm going to add my 4 to both sides to move it to the right. I'm left with 3x equals 6. Divide both sides by 3. Simplified x equals 2. That's it for lesson 83.